Given two non-empty sets A and B, and if measure of A is 0, then we need to check which of these options are correct. Right? So what is given to us? That measure of A is 0 for non-empty sets A and B. Now we don't know that either these of sets are disjoint or not. So we need to take both these cases. So if the sets are disjoint, then we know that measure of their union is equal to measure of A plus measure of B. But if the sets are not disjoint, then the union of their measure is always less than equal to the measure of A plus measure of B. So for the disjoint sets we have the equality sign, and for non-disjoint sets we have the inequality, right? And this property is also known as the property of subadditivity. Okay, let's start the solution. We need to take the two cases for the disjoints and non-disjoint sets and then check the options. The first case, if A and B are disjoint or mutually disjoint sets, right? The measure of the union of A and B is always equal to the measure of A plus the measure of B. It is given that measure of A is 0. So we write here 0 plus the measure of B. That is, we are getting the measure of their union to be equal to the measure of B. So which means A option is correct, right? For disjoint sets. Now let's check the other case for the non-disjoint sets. Number 1, by the property of subadditivity. By the property of subadditivity, we know that the measure of A union B is less than equal to the measure of A plus the measure of B, right? Measure A equal to 0, this is given to us. So right hand side is further equal to measure B. Reason, measure A is 0. So we are getting the measure of their unions to be less than equal to the measure of B by using the property of subadditivity, right? So which means by this property, last option is also correct, right? By property of subadditivity. Let me mark this as inequality 1. It is also known that by the property of monotonicity. What is a property of monotonicity? For this property we know that B is a subset of A union B, right? B is a subset of the superset A union B. So by the property of monotonicity, if I take the measure on both the sides, then the measure of that set is always less than equal to the measure of the superset, right? So by the property of monotonicity, we are getting the second inequality to be the measure of B less than equal to the measure of their union. In the first inequality, we are getting measure of B greater than equal to the measure of their union. Here we are getting measure of B is less than equal to the measure of their union. So if I combine both these two inequalities, combining 1 and 2, we get that measure of A union B is equal to the measure of B. So which means if the sets are non-disjoint, then also we are getting the equality sign, right? By combining these two properties. So which means this option A is still correct for the non-disjoint sets also. By using the property of subadditivity plus the property of monotonicity. Combining these two properties for the non-disjoint sets, we still get the option A to be correct. And simply for the disjoint sets, by using the result, option A is correct. And by the property of subadditivity, we are getting the last option also to be correct. So A and D are the correct options for this question. So answer option A and D both are correct. Alright, thank you.